All right, hello everybody. So today we're going to continue our discussion in chapter 6, sections 3 and 4, and I'm going to show you some examples of two systems that can be solved by elimination, but aren't necessarily as easy as the first example or the second type that we did in the last two videos, where you already had variables that were the same, had the same coefficient, or they had the opposite coefficients. So when you added or subtracted them, the variables went away. So as you can see in this particular first system that we're going to solve, we have 5x plus 6y equals -8, and we also have 2x plus 3y equals -5. Unfortunately, in this system, we do not have the x's or the y's to be the same number or even the opposite of each other, but the same number. So when we add or subtract them, they go away. So we can't just add or subtract this system and have a variable eliminate using this elimination process until we get two of the coefficients to be the same. So the first thing that you want to do is you want to kind of take stock of what you have and decide which variable you're going to make the same. Now, looking at these two problems, I think it would be the easiest to make the y values the same because it's going to require the least amount of work, and I will show you. So what we're going to do here is that we can turn a 3 into a 6 by multiplying it by 2. So that's what I'm going to do. I'm going to take this equation, I'm going to put a set of parentheses around it, and I'm going to multiply the entire equation by 2. Now, you'll see what this accomplishes after I draw my arrows, but we get 4x plus 6y equals -10. Now, why did that help us? Well, if I bring the first equation over, 5x plus 6y equals -8, you will see that both of the coefficients on the y are now the same. And that's good. We want them to be the same because we can get them to cancel each other out now by simply subtracting. So I'm going to take these two like this. I'm going to put a subtraction sign, and then I'm going to proceed to subtract these two equations. So 5x minus 4x is 1x. Now 6y minus 6y is 0. Those cancel. That's what we want to happen. The elimination process depends on us getting one of the two variables to eliminate. Then we have -8 minus -10. That would actually turn into +2. And so what you see is we are actually done with this first part of the problem. X is 2. We found half of our ordered pair. Now we're going to take that answer and we're going to substitute it back into any of the equations that you have. It doesn't really matter in this case because none of them are already solved for y. We can simply substitute it in. I'm going to go ahead and choose this second equation right here to use. So it's 2, and then we have x, so that's parentheses, plus 3y equals -5. Now in place of that x, I'm going to put this number 2 right there. So we're going to have 2 times 2 plus 3y equals -5. 2 times 2 is 4. And then in order to solve this, I'm going to subtract 4 from both sides. And then the last step is going to be to divide by 3 on both sides. And y equals -3. So there you go. We got our x initially, and then we plugged our x in and solved for our y. And so we end up with the solution to -3. So sometimes with these, you do need to multiply both of the equations by a number, but I'm going to show you those in the next video we do after this. So here's number 6. This is going to be very similar to the last one. If you look, the coefficients that we have do not cancel each other out. Okay, you can see we have a 3 and a 9, and then the other one is a 2 and a 1. So we need to multiply one of the equations, in this case, by a number. I think the easiest thing to do is, since this is a 1, it's really easy to turn that into a 2 simply by multiplying. Now I'm going to show you something else. So in the last one, I multiplied by a positive 2 right here, and then we subtracted the two equations. And you can do that. That's perfectly fine to do. The other way to do this would be to multiply by a negative number or the number opposite of what you want. So if I look in this second equation, I would like this right here to be a negative 2. So I'm going to go ahead and multiply this entire second equation by negative 2. So negative 2 times the 9r, negative 2 times q, and negative 2 times 13. What I get is negative 18r minus 2q equals negative 26. And then our first equation is not going to change. Now what you see is we ended up with the q values being the same number, but their signs are opposite. And that's even better than the last one, because instead of having to subtract the two equations, we can just add them up. We're just going to add them. Okay, so I have 3r plus negative 18r. That is negative 15r. And then I have 2 plus negative 2. That is 0, so that cancels. And then I have negative 4 plus negative 26 gives me negative 30. Now, after we get that, we're going to divide both sides by negative 15. And we'll get r equals 2. So we have one of the two numbers of our ordered pair. The other number we will get by substituting that number 2 back into either the first or the second equation. It doesn't really matter. I'm going to use the first one this time. So we'll write 3 and then r. So I'll put a set of parentheses for the r, plus 2q equals negative 4. Okay. In place of r, I'm going to write it 2. So 3 times 2 is 6. I'm going to subtract 6 from both sides. So 2q equals negative 10. And then when I divide both sides by 2, I get q equals negative 5. So I do have both of my numbers now, and I'm going to write them in an ordered pair. Remember, alphabetized. So r comes before q. That's actually not true. Q comes before r. Let me think about this. So in the original problem, they wrote r and then q, when in actuality they should have written qr. So I am going to alphabetize them. I'm going to stick with what I said. It would be negative 5, comma 2, like that. And so there you go. So there's how you solve systems by elimination when you don't have the coefficients, when they're not the same number. You have to multiply one or both of the equations by a number so the coefficients do match and you are able to get them to eliminate. So as always, if you have any questions, feel free to email me. Have a great day.